So section 5.1 or chapter 5, we're going to start using different identities and what we've already learned about the unit circle, what we know about trig, just in general, so katoa and the reciprocals, to be able to prove identities. So not the flowchart proofs that you did before. These are algebraic proofs. And then we're actually going to use that stuff also to solve equations. So I wanted to start with a picture here. Use what we know about the unit circle and Pythagorean theorem itself to take a look at some of the identities. So I have my circle here. I know that every point in the coordinate plane is an x comma y. I know that if I were to have a unit circle itself, so radius of 1, that if I plot any point x comma y on there, I could inscribe a triangle that has a base of x and a height of y. Okay. Using what I know about Pythagorean theorem, so I'm just going to use prior knowledge stuff. I know that if I take leg squared plus leg squared, I have to get, in this case, hypotenuse squared, which is going to be 1. Well, 1 squared is just 1, so let's just go ahead and get rid of that squared part right there. So I know this for sure from the Pythagorean theorem. I know it's just leg squared plus leg squared equals hypotenuse squared. Okay, so Pythagorean theorem, just old school, didn't even have to be inside of a circle. What we want to do is we want to use what we know about trig that we already came up with. So let's take a look at another circle on the coordinate plane. So I went through and moved our circle off to the left that we had already done and just copied down the exact same one. Now we know, based off of our work in the unit circle, that the extra, if the hypotenuse is 1, which it's going to be in this case, we're in the unit circle, that the x direction is actually the cosine of the reference angle theta, and that the y is the sine of the reference angle theta. So I know that every single point, x comma y, is technically cosine theta, comma sine theta. I want to do Pythagorean theorem again. So I had x squared plus y squared is equal to 1. But now I'm going to replace the x with cosine theta and the y with sine theta. Now, since I am doing cosine theta squared, I'm not squaring the angle itself. Theta itself is staying the same. It's actually the cosine that I'm squaring. So it's cosine theta times cosine theta. Theta stays the same. It's actually cosine squared. So we've got cosine squared theta plus same rationale with sine theta all squared. This is going to be one of our Pythagorean identities. This one's going to be huge for us. We're going to use it a ton. Now, what I want to do is I want to actually be able to manipulate this and see if I can get some of the other trig involved. So I'm going to go ahead and copy that guy down. I'm going to start with that as my base. And then I'm just going to start manipulating it. Now, this is an equation, so I have an equal sign. I should be able to do operations. So like add 5 if I want to, not that I want to, or divide by 7 if I want to, not that I want to. I'm actually going to take this first one and I'm going to divide everybody by the very first trig that I see here, which is cosine squared theta. So I'll divide everybody by cosine squared theta. And let's simplify this. Well, I know cosine squared divided by cosine squared, anything divided by itself is just 1, plus, okay, well, sine squared over cosine squared, well, I know sine over cosine, that's tangent. So if sine over cosine is tangent, then sine squared over cosine squared is tangent squared. Same rationale over here. 1 over cosine is secant, which means 1 over cosine squared is secant squared. This is going to be another one of the identities that we use. Okay, let's start back again, see if we can get the other one involved here. So I've got 4 of my trigs so far involved. So I've got cosine, sine, well, they're squared versions, tangent, and secant. So let's go back to cosine squared plus sine squared equals 1. And this time I'm going to go through and divide by sine squared. Just trying to get the other Pythagorean identity. All of these are based off of the Pythagorean theorem. Okay, I know the second one is 1 because sine squared divided by sine squared is just 1. Cosine squared over sine squared, well, cosine over sine is cotangent, so cosine squared over sine squared is going to be cotangent squared. And then 1 over sine squared, well, 1 over sine is cosecant, so 1 over sine squared needs to be cosecant squared. This is my last Pythagorean identity. There really are only 3. But what's really nice about it is that this allows us to relate two seemingly very different trigs together. So the first one, we could get cosine squared and sine squared. Notice that they're squared. And then we could get tangent squared and secant squared, and then we can get cotangent squared and cosecant squared. This is going to be pretty big for us. So if we take a look further down, you can see here are the identities that we just came up with. So I'll go ahead and box those in like a reddish color for us right there. Those are the ones we just came up with. Then we still have the fact that tangent is equal to sine over cosine, cotangent is equal to cosine over sine. When we start doing proofs, a couple rules that you need to follow, and this one's big. You only get to work one side. So you cannot touch both sides of the equation to try to manipulate them down to the same thing. You need to pick one side and attempt to make it look like, and I mean exactly like the other side. It should look like a mirror at the end. So a couple of things. Pick one side. I normally just pick the side that has the most stuff, like the larger mess, because then I can play around with it more. It's easier for me to take a ton of things, try to crush them down into a nice, neat little package, as opposed to taking this little tiny thing and break it apart into a ton of pieces. So pick one side. Use identities. Do not touch the other side. Just carry it down. And you have to carry it down every single row. If you get stuck, go back up and see if there's something else that you could do. I'm not saying don't look at the other side. You absolutely need to look at the other side and figure out where you're going. So if you're dealing with a whole bunch of sines and cosines and you're trying to get tangents or cotangents, well, then you're probably going to need to do some sort of multiplying by 1. Just make the 1 look very specific. We do a lot of multiplying by 1. If you think back to first semester, we would multiply by 1 as like x over x. Well, an example of multiplying by 1 here could be like multiply, for example, by sine x over sine x. That's technically 1. So we're just going to need to make the 1 look the way we want it to. Try adding a 0. So maybe you do plus cosine x minus cosine x. That's technically 0. You didn't change anything. Now, I'm not saying put them right back together again. Like you did that for a purpose. You needed to get some cosines involved. Maybe you reorganize that side so that the cosines are in different places. If all else fails and you're not sure what to do, the side that you chose, turn it all into sines and cosines. Because every single other trig is based off of sines and cosines. Like tangent is sine over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. Every single one of them breaks down into sines and cosines. You have to make sure that it looks like a mirror at the end. So the very, very, very end, you've gone through and you've solved a problem. You've been carrying down the equal signs. And the right and the left-hand side are matching, you're carrying down one of the sides. Down at the very bottom, you get like sine x, sine squared x is equal to 1 minus cosine squared x. Those are not exactly the same. They're not a mirror. However, 1 minus cosine squared x is sine squared x based off of the Pythagorean identity of 1 plus, sine squared plus cosine squared is equal to 1. So you do have an identity in here. So, I'm going to spend some time actually memorizing these guys. Okay, let's actually take a look at some simplification. These are not proofs. You're just trying to do some math. And by do some math, I mean you need to be able to multiply stuff out. You need to be able to factor. Factoring's huge, huge. So You need to get some common denominators. You need to combine like terms. You need to use your identities. There's a ton of different things that come into play here. These are algebraic proofs using trig functions. So the algebra part is still there. So if I take a look at this 1 minus cosine theta and 1 plus cosine theta, this is equivalent to 1 minus something times 1 plus the exact same something. If you think back to integrated 2, chances are you drew this out and you multiplied. You might want to consider doing the exact same thing here. So if I take out a box, and if you don't need the box to multiply, then don't write it out. This is going to be 1 minus cosine theta, 1 plus cosine theta. 1 times 1 is 1. 1 times cosine theta is cosine theta. That's negative cosine theta. Let's actually drag this box a little bit bigger so I have some room. And then negative cosine times positive cosine is negative cosine squared. Remember, you're squaring the cosine, you're not squaring the angle. Take a look at this. The positive cosine and the negative cosine cancel. We actually get 1 minus cosine squared theta, but this is not done because there's an identity for this. So just as a reminder, the one we're going to use a ton is that cosine squared plus sine squared is equal to 1. I have 1 minus cosine squared. So let's move this guy over here. So this is going to be sine squared is equal to 1 minus cosine squared theta. Now let's put it back. 1 minus cosine squared theta is sine squared theta. That is the simplified answer. And let's take a look at the next one. We have 1 over sine squared minus 1 over tangent squared. Okay, I'm going to go ahead and just rewrite my tangent squared as sine squared over cosine squared. But remember, if I'm going to do 1 divided by sine squared over cosine squared, this is the same thing as 1 divided by sine squared over cosine squared. Or years ago, it was keep, change, flip. So this here, well, 1 times cosine squared over sine squared is just cosine squared over sine squared, is going to replace my 1 over tangent squared theta. So I have 1 over sine squared theta minus, take the stuff that I just got and plug that in, cosine squared over sine squared. If the denominators match, which they do, you can keep the denominator and do the math on top. Well, the math on top is 1 minus cosine squared, but 1 minus cosine squared is sine squared. So this is sine squared theta all over sine squared theta, but sine divided by sine is 1. That is the answer. Okay, we have sine x plus cosine x squared. Just a reminder, squared means times itself. This is sine x plus cosine x times sine x plus cosine x. Draw boxes, multiply it out. This is the way you have to do it. Or you have to distribute carefully. What you do not do, this is a hard no, don't do this. You cannot distribute your squareds inside because you're going to miss the term in the middle of the sine and cosine. So why don't you pause, see if you can multiply this out, and then come back and check. So consider drawing boxes. Okay, so I filled in the boxes, gave myself a little bit more room this time, and let's see if we can combine like terms. So I know that this sine x plus cosine x is actually going to be 2 sine x cosine x because they match. 2 sine x cosine x. But I can also combine the other ones. This diagonal, those 2 right there, have sine squared x plus cosine squared x Remember, that's 1 plus 1. That's my answer. Really might want to take some time, make some flashcards, and start memorizing the identities. But even if you can't, you don't know the other two. So I personally do not have memorized the tangent squared, secant squared, cotangent squared, cosecant squared. You are absolutely welcome to. I just know that sine squared plus cosine squared equals 1. And I know I can get the other ones. But if you're trying to make your time a little bit more useful, just spend some time and memorize them. Okay, now let's do a proof. Okay, so if we take a look at this, I've got 2 different sides of this thing. So let's take a look at this left side, and we're going to compare it to the right side. Left side. Left side has a whole mess of things. It's got a 1 minus cosine squared x. I know what that is. That's sine squared from the Pythagorean identity. I've got a mixture of sines and cosines. There's simply more things that I can work with. It's a bigger mess. Look at the right-hand side. I have a cotangent x. That's it. If I started with the cotangent x, I have to somehow turn it into the left-hand side. Combinations of sines and cosines, a 1 minus cosine squared. I have to do a lot more creation if I start with the right-hand side. As opposed to the left-hand side, I just start kind of crushing things together. Now, I am going to go with the left-hand side. That's the side I choose. So I think it's got more stuff and there's more of an opportunity for me to actually get this thing done correctly. So this has more stuff to work with. So that's the side I choose. So as I'm going through and I'm trying to prove this, I cannot skip steps. I have to make sure that I show everything that I am doing. If anything comes from an identity, then I can go straight to that. I don't need you to show me that sine squared plus cosine squared equals 1. I don't need you to show me that 1 minus cosine squared equals sine squared. That comes from the same identity. I don't need you to show me that you know tangent is equal to sine over cosine. Like if you see a sine over cosine, you're like, aha, I can pull that together to tangent. Go ahead. You're using an identity. But you can't just randomly create magic and think that, oh, I'm at the end. Okay, so I see, the first thing I saw was that identity on the bottom. So I'm looking at this 1 minus cosine squared. I know that that is sine squared. So I'm going to replace what I had. So I'm just going to copy down sine x, cosine x, because I haven't done anything with it yet. I'm going to use my Pythagorean identity, and I'm going to replace. Notice that I have equals cotangent x. I'm going to look at every single line. You can't have just nothing on one side of your equal sign. Okay, let's see. Well, sine squared x is technically sine x, so just for ease here, you can write out sine squared x as sine x equals cotangent x. Okay, anything divided by itself is just 1. So from here, I have cosine x over sine x equals cotangent x. Well, yes, of course that's true. But don't stop there because it doesn't look like a mirror. You need the left-hand side and the right-hand side to look exactly the same. So cosine x over sine x is the exact same thing as cotangent x. And then I carried down the right-hand side. Notice the left-hand side and the right-hand side look exactly the same. I'm done. My proof is finished. Take a look at the next one. Pick the side that has the larger mess. It's got more stuff on it. Well, hopefully your eye kind of gravitates to the left-hand side. There's way more stuff over there. Way more. Well, we have to turn it into a single tangent. Okay, so what is tangent? Well, tangent is sine over cosine. It's not a tangent squared, so maybe the identity would help us, but the identities with the Pythagorean identities, they're all squareds. So be careful. We can't just square root something because then you'd have to square root both sides. Not allowed to do that. So I think I'm going to go ahead and work on the left-hand side. It looks like a multiplication problem, so let's just go ahead and multiply it out. So draw your boxes if you need to. If not, you can just distribute. So cosecant x is going to get multiplied to secant x and then to positive 1. Negative cotangent x is going to get multiplied to secant x, which is also going to get multiplied to positive 1. So I think I'm just going to go ahead and distribute and see what happens. So if I distribute, I'm going to get cosecant theta secant theta plus cosecant theta minus cotangent theta secant theta minus cotangent theta. Okay, that's my multiplication, and then carry down the right-hand side tangent theta. Okay, clearly not a mirror. I have a ton of work that I need to do. What could I do? Well, I don't want to factor because that would undo the work that I just did. I think I'm going to turn everything into sines and cosines and see if that helps, because I know tangent is sine over cosine. If I can somehow get that to happen, I'm home free. So cosecant I know is going to be 1 over sine theta times secant is 1 over cosine theta plus 1 over sine theta minus, well, cotangent is cosine over sine times secant, which is 1 over cosine. And then cotangent is cosine over sine. I know it looks like a bigger mess, but with sines and cosines, I think we have a better shot of simplifying this thing. And actually, I can simplify some stuff here. This cosine and that cosine are going to cancel. So from here, may as well just pull this guy together. This is 1 over sine theta cosine theta plus 1 over sine theta minus 1 over sine theta. That's good. Those are going to cancel. Minus cosine theta over sine theta. And we're trying to turn it into tangent. Okay. Well, those guys disappear. So now I've got 1 over sine theta cosine theta minus cosine theta over sine theta is equal to tangent theta. Okay. If these two fractions had the same denominator, then I could put them together. So here's my timesing by 1. If I take a look, the first denominator is sine theta cosine theta. The second denominator would need a cosine theta. Now I'm fine as long as I multiply both the top and the bottom, because cosine over cosine is just 1. Okay, so now I have one common denominator, may as well pull them together. Cosine times cosine is cosine squared. That's good, that's an identity. And then sine theta cosine theta, that's equal to tangent theta. Okay, let's use our identity. We know 1 minus cosine squared is sine squared over sine theta cosine theta equals tangent theta. Okay, one of the signs cancel on the top. You can write both of them out if you need to. If you understand that sine squared is the same thing as sine theta times sine theta, one of the sine thetas are going to cancel out. I'm going to end up with a single sine theta still left on top and the cosine theta. Okay, don't stop. You have to make sure that it looks like a mirror. Left and right hand side need to look exactly the same. And that works. So here, up at this top part here, if I lost anybody, what I did was sine theta over, and if you need to show this in your proof to see the simplification, please do so. There's my sine theta over cosine theta. Okay, let's take a look at the next one. Bigger mess, left-hand side. So choose the larger mess. Pick that side. Let's see. If I take a look at the right-hand side, where I'm trying to go, I am trying to get secant theta. Well, secant theta is 1 over cosine theta. Okay, so that's good. So the second fraction has a cosine in the bottom. That makes me happy. The first one does not. That doesn't make me happy. So maybe I take the very first one. Oh, maybe we just get a common denominator and try to pull them together. Maybe. Let's try that. So I'm going to take the very first one of cosine theta over 1 plus sine theta. And don't be surprised if sometimes you just have to play a little bit. So this would need a denominator of cosine theta added to it, or in addition. So I'm going to put a cosine theta down there. Okay, then I had plus. This one had the cosine theta and 1 plus sine theta on the top. Okay, so the thing it's going to need is the 1 plus sine theta. And I'm just multiplying each one of these by 1, which I'm allowed to do. It doesn't change anything. And then always carry down the right-hand side. I'm trying to get 2 secant theta. Okay, let's do some math. Denominators match, so let's pull them together. So this is going to be cosine theta, 1 plus sine theta. Okay, that's going to give me cosine theta times cosine theta is cosine squared theta. Let's multiply this out. It's going to be 1 plus 2 sine theta plus sine squared theta equals 2 secant theta. Okay, what could we do here? Oh, we have an identity. This cosine squared and that plus sine squared, that's 1. So we have 1 plus 2 sine theta. So I still have the 1 plus 2 sine theta from before. Carry my denominator with me. Combine like terms. I think I can factor. So cosine theta, 1 plus sine theta. I have the cosine in the bottom that I want. But if you take a look at the top, those both have a 2 in common. And I can now cancel the 1 plus sine theta. That cancels, so I'm going to end up with 2 over cosine theta, which is where I need to be. But don't stop short. And remember what side you were working on. Don't flip the other side. That's bad. You've kept the right-hand side just kind of chugging along with you the whole time. Don't start jumping over there. So if we take a look, the entire time I had 2 secant theta equals 2 secant theta equals 2 secant theta. I carried it the entire time with me. At no point in time did I touch that side. Even if you look at the previous problem, I had equals tangent the whole time. At no point in time was there any work done on the right-hand side. Just carried it with me the whole time. Okay, let's take a look at the next one. So on question number 7, oh, well, biggest mess is hands down on the left-hand side. I see that I can factor, actually. So I'm just going to take a look at the top for a second. If I take a look at the top, this is equivalent to u to the 4th power minus v to the 4th power. This is a difference of squares. This is u squared minus v squared, and then u squared plus v squared. So remember about that algebra stuff that I talked about earlier. Got to be able to factor. So let's take the top, and we're going to do a difference of squares. So it's going to be sine squared x minus cosine squared x times sine squared x plus cosine squared x. Okay, so all I did was factor the top. I know I can factor the bottom, but I don't know if that's what I want to do, because now I see that my sine squared x minus cosine squared x matches. So I think I might just want to keep it, because it's also a difference of squares. But I'm trying to get 1 on the other side. So canceling these guys is going to be huge. So let's get rid of those. So they are the same thing. Okay, copy down what we got. We've got sine squared plus cosine squared. That is a Pythagorean identity. That's 1. So although this one looked painful, this actually wasn't too terribly bad in comparison to some of the others.